Welcome to last session of this webinar series on clean code, and thanks for being patient and attending all the webinars. If you have missed any of the recording, then it is available on our YouTube channel, IndiaMentor channel. So you can just visit there, and along with my series, also you can see other webinars that are being conducted by many other IndiaMentor community members. So let's begin. So what is clean code? So this is nothing but statutory warnings and then preface. So let's keep that. Well, I'm working on .NET from last 11 years, and my journey is like I've started as a software developer, and from software developer to become an architect. Right now working for a large enterprise, hands-on architect. So I code daily for living, and that's how I get paid every month. I'm interested in quite a bit software architecture, illicities, and specifically high volume, high traffic distributed systems. And I'm also a beginner in open source technologies, specifically Python and machine learning. So that's about me. Source for inspiration of this talk is Robert C. Martin, or commonly or fondly called as Uncle Bob in our industry. So he's the pioneer, or he's the kind of he's the person who founded or discovered the solid principles, as well as quite a bit many techniques in XP area, along with Ken Peck and other luminaries. He's also the original signee of Agile Manifesto. So let's see the overview. So we'll first go why we should care about the clean code, and then we'll see the definition of clean code. Then we'll see what are the tips for writing the clean code. These are the tips or thoughts on how to write the clean code. And then if we have questions, then please feel free to ask the question in between, and you can also share your experiences, and then we'll wrap it up. Okay, cool. So why care about the clean code or writing about the clean code? So we always say, like, code is just working fine, so why should we touch it? If it is not broken, why should we fix it? But let's see why we should care about the clean code. And basically these are the common reasons that we should care about clean code. Those are like bad code always slows us down, software rots, it is inflexible, then it might take longer to fix the bad code rather than writing from the scratch. Then we can also talk about the cost of ownership and actual calculation if somebody is wants to go into the details of it. So most of the time as a developers, we spend time in reading the code and trying to understand the code rather than writing the code. So if we turn in those things into the hours, and time is money, so we can just by implementing some of the practices of clean code, we can improve a lot on the per week and per year as well, and can have good savings on our time, as well as on we can also improve the productivity. So, but you are still not convinced, right? So let's see why we should do it. For that, let's hear the story of an organization. So once upon a time, there was a company with 4 employees named everyone, someone, anybody, and nobody. One day it became necessary to complete an important task. Maybe it's writing a code or writing a clean code. Everyone was sure that someone will do it. Anybody could do it, but nobody did not do it. Someone got angry because it was a work for everyone. Everyone thought that anybody could do it, but nobody realized that everybody will not do it. In the end, everybody blamed someone that nobody did not do what anybody could do. So that's a funny story that I found on internet, and I think it is quite relevant to our state of mindset when it comes to the fixing the things or fixing the uh, fixing the code basically. So the gist is we should care, and like it's everyone has to be accountable for writing the code or writing the clean code. It's not just like anybody else has to blame for a number of reasons. So we are professionals, and that's our ethos or professionalism, and our professionalism reflects through our work product, that is code. So once if somebody looks at your code, then definitely we can always see, or he can always comment out on your professionalism or the work ethics we have. So definitely it's our own responsibility as developers to write a clean code. So let's see the another story again. So in this story, I mean, the picture itself is a funny and self-explanatory. Like even if somebody invented, if are busy and trying to smart, not smart, then definitely they will still go for their own old ways or practicing the old ways. I also have one story to tell you guys. Like there are story. It's the story of two teams, Team A and Team B. So they began a project. It's the same project in two different organizations, and Team A just like they started on this journey. They were both practicing all the good things like agile and all those stuff, but so Team A started to delivering features and features by features. So their management were quite happy, and because of they are delivering features as per expectation, management has got high expectations from them. So management quite often come to them and asking them to do the features, and as so because of this high expectation, what happened is they put pressure on themselves, and they started to cutting the corners and try to avoid all the best practices, because they thought in their minds that it takes time to write the unit test cases or write a good code. So why should we do it? We just fix and hack the code and then deliver the features, because nobody's looking or peeking inside the code. So why should we care about it, right? Everybody is happy because they are delivering the features. The another team in another organizations has started on slow but steady. They worked hard for setting up the right practices. They deliver sprint after sprint all the features. Performance wise, they were okay from management perspective. So there was no management love that are shown. So no much bonuses or performance awards. But you know what happened over the period of time, so they have no fuss and no glory approach, but over the period of time they kept on delivering the features, and once release came, there was no defect for this Team B. But for Team A, it was a nightmare, because they themselves realized after releasing the software, everything comes back as a defects. So they are just pile of defects, and they cannot move to the delivering the new features. So management would not able, and because of the high expectation they set in the in earlier version of the software, management would not able to understand what happened to this team which were delivering so good, and now somehow they are just producing defects and bugs, and it caused the customer for that company. So the gist is, even if it takes time initially, over the period of time you will get to know why you should write the clean code, and that is nothing but a technical depth concept. So over the period of time, you can see the line here, which is represented in blue for the business value. So initially you can deliver a very high amount of or high features or high number of features. But over the period of time, if we don't pay our technical debt, or if we don't pay or don't fix the problems in our code, definitely the business value diminishes. So it's nothing but a realization that we should not be reckless and deliberate. We should be prudent, basically. So we must ship features with and deal with the consequences of the feature. So we should always keep in mind the features that are going to be production, and somebody is going to or have to maintain it, and that somebody might be only us after some time. So we need to write a clean code for all these things. Another way of looking into it is through our code we are always adding the value to the business. So if we add the visible part of the value, if we add positive value, then definitely those are nothing but the new features and added functionalities. So everybody is happy with this green quadrant. But if we go to the invisible features, again, architectural things or structural features that are again a positive value, because that gives the software ability to scale, ability to be more efficient, more performant. But then if we see the negative side of these two values, then there is rework, that is nothing but defect and technical debt. So we need to, if we want to be delivering the positive value, we need to take care of those things along with the clean code. Some organizations nowadays, everybody wants to be agile, so they say, okay, yeah, we practice agile, we are agile, and we have stand-up. If you ask them, they will always refer to their rituals, like, okay, we have stand-up, we have a backlog, we are doing sprint, we are doing retrospective. But they missed the biggest point of being agile or adopting to the new values, basically agile values. So let's take a question. So the question came here is, why is bad code? Is this name suitable? Why we choose as bad? Well, I just want to distinguish between clean code and not so clean code. So when we say not so clean code, definitely it's a bad code, because we want to prevent it. We want to avoid writing such kind of a messy code or spaghetti code, basically. So that's the reason I'm terming it as a bad code, that's all. So I hope I have answered the question. So let's go to the slide again. So coming back to the organizations which practice these rituals, they miss the biggest point, which is nothing but a feedback. So why we like in agile, the most important part or most important value that we are getting is feedback from the customer as early and as often. So if we are getting the feedback, the customer is saying, okay, we have delivered the feature, and then we need to change that. But as a developer, we resist on that, say, one of the features. And the reason, if we ask to the developer, underlying thing you will realize is the developer is resisting because he knows that this is the same code which has kept him over the period of entire night and over the weekends. So definitely there is, you will see as a business, you will see a resistance out there. So we cannot be, that's the thing. So the gist is, we cannot be agile if our code sucks, if our code is in bad shape or bad state, or you can measure it by any means and then term whatever you want to say, but it's a bad code, basically. And bad code, so another aspect to writing the clean code is basically coding or programming is a collaborative activity. It's not something like only single person writes the code and we deliver it. No, it's a team activity, so it's a collaborative activity. So basically, many people, many other developers are sharing their pieces of knowledge and thoughts inside the code. So if we are not writing the code for other human beings, then definitely it's a problem, right? So that's where the need for need for clean code arises. Definitely we care. So thanks and congratulations, since you are here. You are after even tiring week of hard work. On the weekend we are discussing our craft. So we should be feel proud of our about ourselves, and we should be feeling good about ourselves, right? So any other questions for me, or otherwise we can move to the next section, which is what is the clean code. Any questions, guys? Cool. So let's move on to the next section. What is clean code? So basically, what is clean? That's a tricky question, because formal definition whereby we can just term any piece of code as a clean code. So do you guys have any thoughts what you can term it as a clean code? What are the characteristics of a clean code, or any definition that you have heard from anyone? So I think let's ponder upon some of the characteristics. I think from my perspective, since there is no formal definition, I have jotted down a couple of characteristics of a clean code, and I think those are important. So from my perspective, from my opinion, I think I can term any code which is a clean code, which gives a developer a mental ability to form a mental model within 15 to 20 minutes. So if you go over any new project or new solution, and if you look at that code or piece of code, and you get a basically, just by reading it, if you can get a basic understanding of that code, that's a clean code. Now underlying this assumption, there are some characteristics that has to be exhibited by this code, which is nothing but readability. Readability is a paramount. Then there is a maintainability aspect to it, so it should be maintainable, and cost of change in that code should be low. So say suppose I have never seen a piece of code anytime, or if I'm seeing it first time and I have been asked to fix the defect in that code, so or asked to enhance that particular feature, then definitely I should be doing it quickly. If that's the case, then I will term it as a good code. Then we should also feel confident about the code which is into question. Then testable, it should be testable, and it should have automated test suite along with it. Then couple of minor details is like it should be neatly or cleanly organized, so should be properly having a solution and namespaces. You can see the projects or assemblies or packages, then folders and classes, and last but not the least, it should have a documentation. So now documentation, again, it can be of any form, be it a Swagger documentation or read the docs documentation, but it should have a documentation. Alright, so let's have a question. I call the code is clean code if I follow all the matrices drafted in my organization. Well, fair enough. So we'll see we'll see why it is having one of your definition is having problem, because if we just target about the matrices, then might not be that matrices might not reveal the entire story of the code base. See, because matrices is always taken at one point of a time. So if you are having a trend of those matrices, then definitely it might be a good sign. But if you just take one snapshot of those matrices and trying to see that everything is green and everything is right, then might not be that might not give you the clear idea. But thanks for sharing the definition. Anybody else want to share any of the characteristics they have seen, or they wanted to term it as a clean code. All right, so let's move on. So couple of clean code. So we might be trying to understand the characteristics, and if we understand the characteristics, but how to fix the problem? If say you find or you came across any code base or code snippet which is not fitting to your definition of a clean code, then we should have a clear chalked out roadmap or a path to fix that code, right? So to fix that problem or fix that code, we need to first identify how we are going to identify that code through code smells. So we have seen it in one of my webinar previously, the characteristics of code smells. So these are nothing but dead code, duplicate code, comments, dead comments, and long methods, long parameter lists, conditional complexity, right? So that's how we can identify the good code. Sorry, bad code. Right. Again, we have one more question from audience. The code should be readable and understandable by developers. Right, that's a good characteristics, and that's where I said in the first of my characteristics that any developer who is not even a familiar or who is not even belonging to that particular team who wrote that piece of code should be able to build a mental model or try to understand or should be able to understand that particular code base within 15 to 20 minutes. That understanding might be a basic one that should be able to figure out what are the modules of that particular code base, what are the things that are, and if he has been tasked with either fixing a bug or enhancing that any of the functionality, he should know the exact right places where he can find that thing within 15 to 20 minutes. Now again, opinions can differ. I always welcome other aspects or other views, and I agree to that definition from the audience that came as a question. So let's move on. So that's how. Sorry, we were discussing about how to identify the problem within the code, whether your code is not a clean code or not. So my understanding and overall I think industry understanding is if you can identify the code smells into that particular piece of code which is in question, definitely it is not a clean code, and definitely it has improvement opportunities. So this code smells, we had a webinar on code smells, so we have seen that, so I'll not delve into details of it. Another practice whereby we can identify the problem that particular piece or code base is not in good shape or is not having a clean code is by having a code reviews. The another aspect to it is again defects, and if some code base is still even not conforming to the quality of service attributes or non-functional attributes like performance, security, I will not also term it as a clean code. So that's how, but that's the opportunity, or that's how you can identify that you are having bad code in that specific code base. One more question from the audience: is clean code applicable only for OOPS languages? What about a procedural language, basic, QBasic? I think it is not even related to only OOPS languages. It is quite possible that even basic or QBasic or even C or C++ code is not having clean code, or is having a problem, these problems. So in my experience, I have seen particularly C++ code, which is again like C code, which is having a couple of those issues. So I think I have answered the question, because now if we look at the some of the characteristic, duplicate code is everywhere. It is not characteristics only exhibited by oops, right, oops languages code, or comments, or long methods, or long parameter lists. Those are kind of you can find those kind of smells in procedural languages as well. So it's everywhere. But for scope of this presentation, I'm really focused on the object-oriented languages. So be it a C#, be it a Python, be it any other language that's object-oriented. So another tip for writing the clean code is nothing but refactor. So we identify our problem with these characteristics. So we have this opportunity to question ourselves that this particular piece of code is whether it's a clean code or not, along with this tools like code smells, code reviews, or even if there are defects, or if that particular piece of code is not conforming to the quality of service attributes. So the next part is definitely once we identify the problem, to take a first step in towards the solution is nothing but refactoring. So it is as we have seen again, I did in this series I did one of the webinar on refactoring and refactoring techniques and thumbnails. So I will not go again into the details of those techniques. But definitely I want to reiterate on the characteristics of refactoring. So it's a small behavior preserving transformations, and it can produce over the period of time a significant restructuring, and it's a less risky rather than the big bang refactorings. So some of the refactoring techniques that we have seen is move method, or which are commonly practiced are like move method, move field, extract method, extract classes. We have also seen refactoring catalog, which is on refactoring.com website by Martin Fowler, and we also saw a couple of techniques how to even discuss about those refactoring. So when you are discussing those code smells or piece of code in a question, you can use refactoring thumbnails and evolution charts while discussing along with your peers, right? So next one is solid principles. So all we are trying to achieve is a code which complies to the solid principles. Not necessarily it is like the code should be complied to all the 5 principles, but definitely the highest priority principle is single responsibility principle. We have also seen those principles, so I will not go into the details of it. So it's a single responsibility principle, open close principle, Lisco substitute principle, interface segregation principle, dependency inversion principle. Letting me know. So the next part is nothing but naming. So naming is quite important again for writing the clean code, because clarity, naming gives the intent or clarity. So suppose there is a methods in my code base or in the same class, basically get from DB by ID, or get customer records, or get client records. Basically all these can be, if somebody finds all these 3 methods in one class, honestly it's kind of confusing, because what we are trying to achieve here is nothing but get customer. So if we have a single method and we pass the searching criteria to this method, I think that will be the cleanest code or clean code in this case. So that's the power of naming, right? Another example of power of naming is .NET framework classes, basic classes. Nobody has actually, I don't think that any .NET developer has been introduced or they have been taught toString method, right? But we always know that there should be a string class, there should be a toString method. So that's a power of a naming, or power of a intent revealing naming. Then one of the another tip is single concept represented should be represented by the single term throughout the code base. So for example, in some classes you will find, or in some methods you will find client as a term used by any developer or programmer, then customer, but you need to be unified, or you need to be using single term. Same thing with the example of a portfolio or account. Should we call it as a portfolio, or should you call it as a account? But my preference is whatever that is used by business, and if business uses terminology, any term, alternatively you should pick and choose one and stick to it inside your code base, so that everybody will having a shared understanding, or common understanding, or common ground, basically, that if we call it as an account, it is account, it is not anything else. Then we have also seen don't repeat yourself as a question, sorry, as a principle. So duplication, basically it just says avoid the duplication, and it is the single most evil. If you can kill something, or if you can fight with some of the characteristic, you need to fight with the duplicate code inside your code base. Another principle is keep it simple. So it's a no-brainer, so keep it as simple as possible. We should not be writing clever code, but a clear intent revealing code, right? So I see there is a question coming. Is recursive method an example of a bad code? Again, we need to see into the context. Secondly, since it's a method, and if it is a recursive method, I presume that it has only single purpose. Then we need to also see what are the names or variable names, method name, what kind of a naming convention that has been used. So it really depends on the context, but I don't think as a construct recursive method is bad. Then one thing, even if you are having a code base which is not a clean code, and you know that there are problems basically with that code base, what you should do is you should try to practice, and say suppose you are not getting enough support as a developer and you are getting annoyed just by looking at the code, or trying to do the code reviews, or trying to actually fix something. So you should always practice boycott rule. What boycott rule just says is whenever you open any file or any piece of code, you deal with any piece of code, you need to leave that code. Once you are done with your work, you should leave that code base or piece of code slightly much better, in a better shape than what you visited. So that's nothing but a minimalistic incrementalism, and that way you can actually have smaller wins. So you will not, over the period of time, you will not need actually anybody's kind of a support in terms of say time or resources, and still you will be able to turn out that code base into the clean code. So yeah, I mean, and just as an example, it's a quite small, it might be a very small thing like changing local variable name in a method. Flags are bad, so obviously prefer polymorphism. So if else based programming is not always right. Then keep all the boilerplates out of your way. So config, error handling, validations. The best part is you can use aspect oriented programming for taking care of those things. But it also might help you to as a developer, it also might help you to clean out or put the business logic in the spot in your eyes. The question is coming, why should I care about clean code? I am the only developer working. Well, even if you are, that's an interesting question, and thanks for that question. Even if you are only developer working, your memory is like we tend to forget so many things. So even if after, say, after 2 months or two, like forget about 2 years, but even after 2 months or 6 months you came back and try to visit your code, you will find that you are having hard time understanding that code. So I think it's still quite relevant, right? And still you will be maintaining, even if you are only developer, you are still maintaining that code, right? So you should be also feeling confident, even if after returning back after several years or several months, it should be quick for you. And I'm not sure if there is a, if you are not practicing clean code, how that is possible. I think I have answered the question. So another tip from myself is try to think in terms of a Unix philosophy. That's a fantastic, Unix is a fantastic operating system. Apart from that, whatever the programming philosophy that Unix practices, that has a great value. And over the period of time, we have realized that it's basically again stating, make each program do one thing well, do a new job, build afresh rather than complicated old program by adding the new features. So one of the great construct from Unix is piping the commands, the command line tools, and that's a great construct, because that way it can keep all its programs lean and still build a powerful, or the most powerful operating system in the world. So these are kind of again inputs or tips for writing the clean code. And I'm not saying that we have to there is no action items, but whenever we are trying to think about clean code, we should be thinking about those principles which are mentioned in the here on the slide as a Unix philosophy. All right. So again, question: can you share some experiences as your first solid refactoring? Well, first thing is, what I realize and what I have is I have faced as a thing is, I read about solid principles and I tried to rush to the trying to implement solid principles, saying that okay, so I'm going to program for single responsibility principle, or I'm going to program for interface segregation principle. But I failed miserably, honestly speaking. So because the thing is, I have not been thinking in the right direction and trying to just comply to the buzzword of solid principles. So I failed, and second time later, somebody who's quite senior to me asked me for the code review. Then they walked through me all my code, and slowly, and in fashion of a boys code rule, we fixed that entire class basically. So that's how that was my first experience across refactoring as well as solid principles, and that's how I learned. So and I think it is, even if it is right now, it is quite evident that once you write the code, it's not going to be perfect one. You have to reiterate, and you have to keep thinking about yourself. And the best way to do that, in my experience right now, what I practice right now is I write the unit test first and then try to write the code. That way I keep check on myself and keep forcing myself to write a clean code. And it's one of the instrument. I'm not saying that if you are writing the unit test cases you are writing clean code. That's one of the aspect, but it's not 100% complying to the clean code, because you can still write the unit test cases but with the bad variable names or bad naming conventions or bad intent, not intent revealing things, or keep all the dead code or comments and all the stuff. Yeah, that's my experience. Thanks again for asking. All right, so moving to the next slide. So comments, if you need to comment on to explain some code, then definitely that's not a good sign. That's not even sign of a clean code. So I think if we comment, we should comment for why, that is intent of that code, what that particular code is trying to do, and not how it is doing. So you should not then another thing is that I observed with the comments is people, there are two types of comment. People comment code, that's the first thing which should be straight away deleted, but they keep it, oh okay, I can come back to this logic and then maybe it might be it might be handy for myself and all those stuff. But if you are able to understand particular logic, then you should not keeping those comments, you should just delete it, because I think once you understand particular code, you can write it again and again. So don't worry on that front. So you can delete that comment. That is dead code. Another type of comment is on top of methods explaining or trying to explain the method well, intentions or method structures. On that front, I have seen some code bases which are quite green, meaning they are marked with so many comments, and those comments are like not useful basically, or not even kept up to date. So method is doing something different, or that parameter does not exist, and still comments are saying some different things, or missing the parameters basically. So, and even there are tools like ghost docs and all those are okay, but you should not overuse it, and you should not be commenting each and everything inside your code base. Comment it very precisely where you need, and if you are needing comments too often, then definitely you have a problem with that piece of code. Another sign is this is again old habits don't die hard. That is changing. We can see the change history headers, and those are so 80s actually. It's kind of it's just indication that either people doesn't know version control system, or they are coming from some different like 80s or 90s background. There's no way you should, I mean, with the modern version control system or even with subversion, you can still track down your change sets or commits, and then you can get the name of person and what he's done or what she has done. So those are the bad things. Then separation of concerns. So keep your packages, modules clean for single purpose. So it's nothing but single responsibility principle magnified across the system. Then try to avoid returning nulls. Null is a bad concept in programming. Even the creator of null is kind of there is a story which says he's regretting that decision of inventing the null. But apart from that, I think it becomes a problem because you will have a literal code across the code base checking those nulls and all those stuff. So, but the solution for that problem or null problem is use the null object pattern. If you are using null object pattern, you don't need to literally check the null every time. And null does not indicate anything. So it's kind of a emptiness that's it is indicating. Testability, as I said, first, if now there are two cases. Some people have automated unit test cases or test cases, or even integrated test cases. Then those are good. But if the code base in question or the piece of code that is in question does not have unit test case suite, then definitely you should first see whether you can write the unit test case. And even before that, we need to check whether the code is testable or not, meaning that can we write a test across that code base. If that's the case, then the obvious step is writing the unit test case. The reason tests are important is because it gives us the confidence and trust that yes, everything is right, everything is good as developers. Another purpose that test serves is kind of a documentation. So if people are arguing comment as a documentation and rest of the stuff, then they should actually not looking into the comments as a documentation tool, but unit test cases or test cases as a acceptance test cases as a documentation tool. Um, for me, I think test or unit test are should be exhibiting these first first characteristics. So first came from the initials of these characteristics. So fast, it should be fast, it should be independent, it should be repeatable, self-validating, and timely. So guys, any question? Alright, so I'll move to the next one. So now, apart from all these things, there are other aspects or other factors which impacts or which try to impact on the code basis, and which also implies whether the code is good or clean or not. So other factors are somebody has said, like, I keep checking my matrices as one of the factors. So yes, matrices is good, but if those are having wrong goals, or if you are trying to track the wrong goals or review the wrong goals, definitely you will land up in a bad. So the reason is, whatever we review, that gets done. So if we are reviewing the code coverage, let's say code coverage is one of the goal, and itself as a matrix or as a KPI, it is one of the tools to measure your code base health, right? But if you give a mandate like, okay, we should having now we understand the unit test cases, importance of it, and the clean code, we should do the clean code, so get me 90% of the code coverage. If you have such mandate, definitely people will try to just achieve the 90% of code coverage by any which way. And I have seen the code bases which are having good code coverage, but just because of such kind of a mandates from the managers or somebody on the top, people are writing the test cases which are not having a value, which are not trustable, which are lacking assets. That's a serious case. So it's kind of a lying to yourself that, okay, everything is good. So be cautious about the matrices. Matrices is good because that gets things done, or you can actually see the status, what your development or engineering teams are doing, but take it with pinch of salt, right? Again, code reviews, people have different implementations and different kind of understandings of code reviews. So again, it's a good tool. Try to use it in the right fashion. Versioning and traceability, version control systems, branching and merging strategies. Then continuous integration environments are nowadays become a norm, but it is very, very important, and it is really good tool to deliver clean code. Because one of my, now it's my perspective again, but one of the characteristics that I believe clean code should have is no defects, or say almost like no logical defects basically. So continuous integration helps in that matter, and it can prevent basically going something wrong or like leaking something bad to the production. Then defect tracking, yes, it is important for two reasons. First thing is, we know despite all these practices what went wrong through the defects, and if we have good defect tracking system, that's really shows us our progress over the period of time. Secondly, we can also see the root causes, okay, why defect has came, rather than asking just to reduce the defect count or defect numbers. We can prevent defect from reoccurring and prevent and that's just, defects is nothing but just like losing the productivity and productivity time, right? So that's where your money is draining, or even the developers get burned out and eventually they might leave, right? So those are the things that constitutes, I think, that constitute the tips for clean code, right? So I think that's it from my side. So if you have any questions or any comments, That will be good. And guys, floor is open, so I think even if you want to share your experiences, go ahead and share your experiences. Otherwise, if you have any questions for me, I'll be here answering the questions. But